What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we wrap up our work with basic sequences and series. In this video, we are going to take a look at some applications or an application of sequences. So in problem number 10 here, we probably have a method that we could actually do this problem, but we're going to use a sequence to answer problem 10. It says Jack already owned 1,420 shares of stock when he got the opportunity to purchase 175 discounted shares per year by working for the company. So he's working for a company, and every year he can add more shares of the stock into his valuation. So currently he owns 1,420 shares of stock. It says in A, if he made no purchases other than these discounted shares each year, how many shares will he have 9 years later? Well, first we need to figure out a sequence for this. And so basically what we can do here is we can give this first number a term. We can say this is A sub 0. This is where he's starting. And every year he's going to add 175 shares. So we can kind of write a sequence or an explicit form for a sequence by starting with 1,420 shares and every year adding 175. So I can go to the calculator really quick and kind of show you this. So 1,420 would be before he started working. And after the first year, A sub 1 would equal 1,595. And then A sub 2 would equal another 175. So that would be 1,770. And then A sub 3 would equal another 175. And so basically what you can see here is to get the shares after 1 year, we're adding 175 once. To get the shares after 2 years, we're adding 175 twice. To get the share after 3 years, we're adding 175 3 times to get to that 1945. So if we want his shares, if we want to know how many shares he has of the stock, we can add 175 in times. So for the first year, we would add 175 once. For the second year, we would add 175 twice. Let me show you how that works here. So let's take that 1,420 plus 175 times 1. This should be A sub 1, and it is. Let's try another, 1,420 plus 175 times 2. This would be the second term, or A sub 2, which is 1,770 that we already found, and this could continue the pattern. So if we want to know if he's making no other purchases other than these shares, and we want to know 9 years later how many stocks he owns, we can do the 9th term in this sequence by taking A sub 9. So I can do 1,420 plus 175 times 9. So initially what we did here was we established that he's adding 175 per year. And so we could use a recursive formula. We could do a recursive formula, A sub n, which is equal to A sub n minus 1, the year before, plus 175. But it's a little bit easier for us to write an explicit formula or a general form for the purchases of stock or the amount of stock that he has. So that way we can easily find the 9th year, the 10th year, the 30th year if we need to, or maybe even 100 years. If he worked for a company for 100 years somehow with modern medicine, we could find how many shares he would have at that time. So where this is important for us is problem A would be not too bad to figure out his shares 9 years later. We just add 175 9 times if we did it recursively. But in part B, it says if this trend continues for 25 years that Jack will work for the company, how many shares will we have at retirement? So let's try to avoid using the recursive here, because if we wanted to figure out the 25th year, we would have to add 175 25 times. It works, but it's a little bit easier here to use the general formula that we created, where we can substitute in 25 for n. And now we can find that over his 25 years, he's going to end up with 5,795 total shares after 25 years. Sorry, I labeled the previous one incorrectly. Let's change that to shares. So here we see a couple examples, or an example of how we can use a sequence to model a situation and to use either the recursive or, in this case, easier to use the explicit formula to answer a question. As always, thank you guys for tuning in, and we'll see you soon.